Routing Policy Part 2. Well, when you finish up Part 2 of this routing policy section here of this CBT nugget of the JNCIA series, you'll be ready to go and jump into the RIP version 2 lab and the OSPF lab. In this continuation nugget here, we're going to explore prefix lists. We're going to look at route filters. We're going to learn about all the different match types and the common actions that we can take in our routing policy, import and export. We'll look at policy flow, and then finally we'll look at an example, kind of a case study of a simple implementation with OSPF. Sound good? Let's get started. The most effective way to learn about a prefix list is look at this configuration listing. Now let me remind you about these configuration listings here. We're in the edit policy options hierarchy of Junos. We do a show command, and what we're seeing here, first of all, are these container statements in the curly brackets. So we've got a prefix list here. We've named it RFC 1918. So this container starts here. You can see the open curly bracket, curly brace, and we ended up here with this closing curly brace. So this is a policy options container statement. Now whenever you see a semicolon like we see here after these three listings, these are our leaf statements. Okay, this ends a hierarchy. In other words, there's no subordinate statement or no subordinate object after these particular prefixes here. And you can see we've got one here after the then reject command. We've got one here after the or longer reject command. And we're going to be seeing a lot more configuration listings as we keep on continuing in our progress, getting ready for our on the job at Nugget Lab. So we want to get used to these. Now what we're looking at here is a prefix list. And we're going to select some routes based on their prefix, okay? And we can see here, and this is a very practical one because it's RFC 1918. So these are typically private RFC addresses that we wouldn't use on the internet. As a matter of fact, the service providers are going to go ahead and drop any of these. So what we've got here is a named list of prefixes under the Edit Policy Options hierarchy. And we've got three of them here, 10.0/8, 172.16/12, and 192.168/16. Now one of the cool things about prefix lists is that we can use them in several different places. We could reference prefix lists in a term or in multiple terms in a single policy, or we could reference them in different policies. Also, we can implement prefix lists for routing policies as well as what we're going to learn later on, firewall filters. Now we don't use them in stateful firewall rules as we'll find out, but we can use them in firewall filters. So these are reusable objects. This prefix list RFC 1918 could be used in some other implementation. Now we have two different ways that we can leverage these prefix lists in the from statement of our routing policy. Let's look at this first policy statement nugget 1. Obviously, as we know, the from is going to be the criteria, or in this case, the criterion, because there's only one. What's the criterion? Well, is there a match in prefix list RFC 1918? In other words, does the route match one of these three prefixes? Now, it's only going to be a match if it matches exactly one of these prefixes, okay? /8, /12, /16. Now, what happens if it matches exactly? Well, the action, the then, is to reject. Now notice down here in the next policy statement, nugget 2, our from is a prefix list filter. When you reference it in a prefix list filter statement, you can actually designate a match of type exact, which we haven't done here, but we've got exact, longer, and the or longer. Okay, so this or longer here is one of three options we have in this prefix list filter. Longer, or exact. So we have these other characteristics that we can apply to our RFC 1918 prefixes. So what we're saying is here, if anything is 10.0.0.0/8 or longer, 172.16.0.0/12, in other words 13 to 32, or 192.168.0.0 or 17 through 32. If it's longer, then we'll reject it. We'll talk more about match types coming up here. Now, the prefix list is one way to do this. Another way is to use a route filter. Well, like prefix lists, route filters are lists of prefixes, and we configure them within a single routing policy or a policy term. But there are some differences, okay? The prefix list was a reusable object, a reusable component that we could actually implement in other things. Route filters, however, are specific to the actual policy or term in which they're configured. Now, they have some advantages, as we're going to see, because they have a few extra match types for choosing our prefixes. And we're going to talk about those match types that we use in route filters. But let's take a look here at this particular syntax. We're in the edit policy options hierarchy, okay? We've done a show command to show our configuration. We still have our constructs with the open and closed braces, which are containers, and our leaf objects with the semicolons. Now, this is not how we configure these. We'll look at that syntax for configuration when we actually get into our labs. But we've got a policy statement, nugget 1, and here's our term. Our term is named, the logical name is reject 1918. That's what we're going to do. So our classifier, or the from statement, has 3 entries. And we can see here that this is a little bit more compact in the prefix list, because we've got route-filter, and then we've got this prefix with the or longer match statement. As a matter of fact, all 3 of them use the or longer match statement. So if the route is 10.0.0.0/8 or longer prefix, then we're going to reject it. Of course, then is our action. Now, this action here, remember, reject, is going to be executed immediately after we find our first match. So upon the first match, we take this action immediately. It's really important to master this, that we understand and master the match type. So let's take a look at those next. Okay, here are our match types. Very important that we learn this. There's 6 of them. There's exact or longer. You've already seen those 2. Longer, up to, prefix dash length dash range. I'll just call it prefix length range, and then through. Let's look at the first one here, exact. Exact basically matches the specific prefix and mask exactly, okay? So we see the from statement and then route filter 10.10.0.0/16 with the exact match type. So only routes that match this prefix exactly will match this filter statement. What about or longer? We've already seen that one. This is going to say that routes within a specific prefix within a specific length greater than or equal to the given prefix length match that filter statement. For instance, so the exact route of 10.10.0.0/16 would match. In addition, all routes that we would call, let's say, subsets of this network would also match the statement. So anything of 10.10.0.0 with a prefix of 17 through 32. So that could be, 10.10.65.0/24, 10.10.24.199/32. You get the idea. Now, what wouldn't match this, and the reason why I'm giving you these examples is because on the exam, you're going to have to be able to tell. They're going to give you most likely 4 or 5 different prefixes, and you're going to have to say what's going to match this route filter statement. Okay, you'll get a handful of those. It's also important, obviously, for the real world as we formulate our policy. So, for example, 10.0.0.0/16, that wouldn't match because the first 16 have to match. 10.11.0.0, that wouldn't match this statement. Let's look at longer. The longer means that routes within a specific prefix with a prefix length greater than, there's no greater than or equal to, but greater than would match. So the only difference between or longer and longer is that or longer actually includes the actual prefix. Longer wouldn't include 10.10.0.0/16. So basically, the longer match type would say 10.10.0.0/17 through 32 would be a match, okay? What about up to, okay? Up to is a lot like or longer, okay? Actually, it's pretty much the same as or longer. with the exception that it provides an upper limit, right? So obviously the longest possible prefix is 32, so or longer is always going to go from whatever the prefix is up to 32. With up to, we're just giving it a range, right? 10.10.0.0/16 up to /24. So things like 10.10.70.0/24, that would match. 10.10.128.0/18, that would match. Okay, what wouldn't match? Well, 10.10.0.0/25, that wouldn't match. 10.10.24.70/32, that wouldn't match. Okay? Now, the next one, prefix length range, is similar to up to. This one gets kind of long. So from route filter 10.10.0.0/16, prefix length range, and then we're going to put in here /20 through /24. So it's similar to the up to, except it offers both a lower and an upper limit to the acceptable prefix length. So it has to be, greater than /20. It has to be greater than or equal to /20 and less than or equal to /24. So 10.10.0.0/20, that would match. 10.10.128.0/21, that would match. 10.10.64.0/24, that would also match. What wouldn't match? Well, 10.10.0.0/16 wouldn't match. Okay, it has to be between 20 and 24, or greater than or equal to, less than or equal to. So 10.10.24.80/32, that would not match. Okay, through is in a category all by itself, and you really have to kind of understand the binary tree, or what we call the J tree here in Junos, to really master this one. We're not going to worry too much about it, okay? I'll give you the base definition. We'll explore this as we get farther along and deeper into our knowledge. But here's what happens with through. The through match type basically says, I want to match all of the prefixes that are directly along the binary tree or the J tree from 10.10.0.0/16 through 10.10.16.0/20. So basically, this second prefix here, it must be a binary subset of the first prefix, which it is. So this match type would match this second, more specific prefix and the next most specific prefix of which it's a part, and so on and so forth, all the way between the first and second prefix. So for example, 10.10.0.0/18/17/19, they would all be a match. Well, now we've seen a bunch of stuff that can happen after the from statement, right? Our different match types. Now let's look at some of the most common things that we can have after the then statement, or basically our actions. Now, a couple of things that are obvious are the accept or reject. So whatever matches, we're going to accept it. Whatever is rejected, we're going to reject it. For example, we might accept direct protocols. We might accept certain static routes. We might accept anything from the RIP protocol, for instance. We also saw reject, where we might want to reject RFC 1918 prefixes. Now, these two actions here are called terminating actions. These terminating actions are extremely important because remember from earlier, in Routing Policy Part 1, I established the fact that if a route matches all of the conditions in a from statement of a term, the Junos is going to execute all of the actions that are specified in the then statement. That's what we're looking at here. Now, if one of those actions is a terminating action like accept or reject, then that policy evaluation is going to stop. These terminating actions basically give us a result of a first match policy evaluation. Why? Because Junos takes this certain action immediately and then doesn't perform any further evaluation. Now, other actions are used for flow control. So for example, if there's a match, we want to go to the next term or go to the next policy. So we can have very elaborate hierarchies here. We could also do some things that are modifying. Now this is just one example of a modifying of an attribute. We have quite a few of these, especially with BGP, which we'll learn about in the future. But for example, we could say if something matches a particular route, then we could affect the route preference. In other words, we could rig the game, make the route preference higher or make it lower. For example, if a static route matches, we can make that preference something that's greater than 1, and we call that a floating static route. And actually, the static route has a preference of 5 by default. So your floating static route would have, based on your policy action, you would give it something higher than a 5. So if you had, let's say, 2 static routes, this had the default with a preference of 5, and your policy was applying a modifying attribute of giving it a preference of, let's say, 7. This static route right here could be floating. So if this route goes down, then this one would become available because there would be no static route with a number lower than 7 available. So that's just a simple example of how we can use the preference as a policy action. Now, something else to keep in mind as we go through this is there's really 2 steps to this process. Step 1 is to define the policy, and that makes sense, and step 2 is to apply the policy. Okay? Now remember, we define the policy, and this is testable. We define the policy in the hierarchy Edit, Policy Options. And I'm driving this point home because on the exam, for example, you may see some sample output on your questions. Always make sure that you're in the hierarchy when you're showing the configuration, that it's under Edit Policy Options to make sure that you get the questions on the exam correct. Now, when we go into our configuration labs coming up, that's the area that we're going to be in when we create our policy statements and our terms and our from and then and all that good stuff. Now, it's important to realize that as we get more experienced and we get more knowledgeable with our import and export routing policies, that we realize that we can chain these policies together to create quite an elaborate hierarchy or a cascade of policy processing. So for example, let's say here's our route 192.168.64.0/24, and this route comes in to be evaluated by a policy. Let's say mypol1. Okay? Obviously, we're going to have a term, so we'll just say term 1. At this term, which we know has at least 1 from and then most likely, we can have a terminating action. We can say if we accept or reject, that's going to terminate the policy, right? If not, we'll move on to term 2 to evaluate this route. If there's a match in term 2, we know that we can accept or reject there. What about term, this should be a 2, by the way. Then we go to term 3. We know if we accept or reject as a terminating action, we'll stop there. But then, after term 3, we could then go over to my policy 2, okay, or my POL 2. Same thing happens here. We've got term 1. If there's a match, we can accept or reject. Then we've got term 2. If there's a match, then we can accept or reject. Then we go to term 3. If there's no terminating action, then we'll move on to our next policy, which we would say would be policy N. So we can just keep on going. We would do this to basically solve an extremely advanced or complex route manipulation policy and do it in a modular fashion. Remember, if the first policy, mypol1, doesn't match, or if the match that happens is associated with a non-terminating action, like flow control or a modifying attribute, then Junos will evaluate that route against the next policy in the chain, and it keeps on going for all of the policies in our cascade. Now, what if there's no match? Well, remember the default policy? Ultimately, Junos would apply the default policy for whatever protocol we're dealing with if there's no terminating action while evaluating our user-defined policy. Now, we've seen some very simple configuration output. And remember, Junos is going to list those terms sequentially from the top to the bottom, and it evaluates them from top to bottom. And we can, of course, see that with our show command. And as we learned, the next term action or the next policy action, if there's a match right there, it would cause Junos to say, hey, let me go evaluate the next term or the next policy. So I can basically force that, I can control the flow within my actual policies. Let's take a look at a simple example, kind of a case study here of how we can apply this, and then we'll have the big picture. We'll be ready to configure this when we get onto our Junos routers in our RIP version 2 and OSPF labs coming up. Let's look at a simple OSPF example that you will probably be responsible for on the exam. So here's our link state protocol OSPF. This is our single area. So you can see this is area 0. That's all we're dealing with, is just one area. Here's what we want to do. Here's our objective. We have a static route configured on R1. And this static route points to the service provider or the ISP. So you can see this network here between the customer edge router, router 1, and the internet ISP is the network 209.165.200.0/30. So because of the /30, there's only two valid addresses on this point-to-point network, .1 and .2, because 200.0 is the network and 200.3 is the broadcast on this network, and then 200.4, because of this prefix, is going to be the next network, right? So we commonly use this on these links going to service providers or branch offices, so on and so forth. Well, we have a static route configured here. However, what we want to do is we want to advertise that static route into our OSPF domain from this router so that all these other routers on behalf of the devices behind them, right, if they need to get out to the internet or the destination packet is not for something in this corporate LAN, we want to, by default, route it out to the internet through router 1. That's our goal here. Now, we've already got a static route configured on router 1, and you know how to do that. If we did the show route command, it would basically be, 0.0.0.0/0, and it would be a static. It'd have a route preference of 5. We established that. And basically it would be to 209.165.200.2 via whatever this interface is. So let's say this interface is gig E001 unit 0. Okay, so we understand that so far. Let's look at the policy statement that we would configure for this scenario. Now you might be saying, Michael, why are we doing it this way? Why don't we just jump onto the router and just start configuring stuff? Why are we looking at the actual result configuration? Well, again, this is the best way to do it. Okay, you want to be able to visualize this and see the results, the big picture, before we start configuring our routers. And so when we break this down, it'll make so much more sense to us. Now, we always configure this under the hierarchy of edit policy-options. I established that, okay? So we're doing a show command under that hierarchy at that level. So what we have here are a couple of user-defined objects. The first thing is our user-defined policy, right? This is going to, if it matches, if there's a match, it's going to override the default policy, again, for OSPF. Now, we're using the policy-statement command, and then this right here, def-stat, sounds like a great hip-hop name, doesn't it? Defstat. But it's not. That's just my name of my object. This is just default static. That's what it means. And then, of course, this is a container, so we've got our little open paren here. This is our term, our first term and our only term. We're naming this term except defstat. Why? Well, it's very intuitive, right? What are we going to do with this term? We're going to accept the default static route, right? So here is our match criteria with the from statement. So we're going to match two things. This is a logical and. First of all, if the protocol is static, okay, if it's a static route, remember the route that we're talking about on this router, and again, this protocol could be a lot of things. It could be protocol BGP, protocol RIP, protocol ISIS, protocol OSPF. It could even be things like protocol aggregate or protocol generated or protocol direct. Those are all types of routes as well. But it's protocol static. And the route filter, we've seen route filters before that are things like, 10.10.0.0/16 exact or longer, things like that. But here what we're going to say is this route filter is on 0.0.0.0/0, a default route, and it has to be an exact match. So if the route is a static route and it's exactly this default route, then we're going to accept it. Now remember earlier there was 2 steps. First of all, we have to define the policy. That's step 1. What was step 2? It was to apply the policy, right? Now we know that this policy can be much more elaborate. I just talked about that. We can have quite a complex routing policy flow, but you know what? We're not there yet, right? So step 1 is define the policy. Here's our policy. Now, the next thing we have to do is we have to apply this so we can get these default routes over to router 2 and router 3 in our OSPF area 0. So what are we going to do? Well, we're going to use an export policy. Remember, our policy can be an import policy before it gets to the routing table, or an export policy after it gets to the routing table. So obviously, if we're going to define a static route in router 1's routing table, this is going to be an export policy, right? Because we're going to define the static route, remember, 0.0.0.0/0, and then we're going to export that basically at the protocol level, so that router 1 will start advertising the default route as a particular advertisement. Specifically, it's an external link state advertisement to all the other routers here in area 0. What would that look like? Okay, so here's the configuration output on router 1 after we've applied our export policy. So you can see the hierarchy we're in here is edit protocols OSPF. Obviously this is for an OSPF policy. So I've done a show command here in configuration mode. Notice we've got an export policy, right? This could be import or export. We understand why it's export. I explained that. And here's the def stat. This is the policy I created in the previous screen, right? And what is it for? Well, it's for area 0. But here we've got our area 0 defined as 0.0.0.0. You can define it this way, like an IP address. It's really an effective way to do it. So we've got our area 0, our only area, which is a single area OSPF implementation. And notice that up here, I had gig E001 unit 0. This was the link up to the internet, right, to my service provider. But I've got 2 other links here. I've got a link going to router 2 and a link going to router 3. So this link right here is interface gig E002 unit 0. This interface right here is interface gig E003.0. So both of these particular interfaces are in area 0. So I'm actually going to advertise based on this export policy that default static route 0.0.0.0/0. I'm going to export that static route in link state advertisements to these other OSPF neighbors, router 2 and router 3, so that these routers can inject those into their routing tables, and then the endpoints behind them on their subnetworks that are participating in OSPF know that router 1 is basically their default gateway, or the router of last resort. And so the default route is going to go up to router 2, and then router 2, of course, has its static route up to the internet. If you were to go under router 1, for example, into operational mode and do a show route protocol static command, you would see on the routing table of router 1 that it would have 0.0.0.0/0, and then it would have 209.165.200.2 via gig E001.0. This is a very practical example, a very practical policy, especially for a small to medium-sized business like Nugget Lab. Okay, in this JNCIA Nugget Routing Policy Part 2, we covered 6 main topics. We discovered prefix lists, route filters, the 6 different match types, common actions that we can take, terminating actions like accept and reject, flow control actions like next term or next policy. I described policy flow for complex actions for complex import and export policies, and then finally a very simple but practical real-world example of a single area OSPF domain where you wanted to advertise through an export policy the default static route to the service provider into the OSPF area, into the other neighbor routers. Well, you're now ready for the 2 deployment labs, RIP version 1 and OSPF, coming up next. I hope this CBT Nugget was informative for you. I want to thank you for viewing.